I see that the last couple of videos have been so great. You are coming back for more. Or maybe this is the first one and you said, what the heck is completing the square? You're about to find out. So again, completing the square, none of these methods are necessary by themselves for this class, but they're very useful and the topics are used in future classes. So that's why I'm kind of talking about this here. Completing the square is something that will always work. Unlike the first two methods, it will always work. Sometimes it's really nice and pretty quick, and sometimes it is not. So here we go. I'm going to show you how it is. You may have seen it before. Example 3. Solve by completing the square, often abbreviated CTS. I love abbreviation. So part A, this is going to be the good case, the thumbs up case, if you will. X squared plus 4x minus 21 equals 0. So the whole idea about completing the square is to try to get it to look like this so we can use the square root property. So we want a perfect square on the left. So the first thing we do is move this over. Well, let's add 21 to both sides. You get x squared plus 4x equals 21, and we leave a little blank because we want the left-hand side to become a perfect square. Now, if you are a mathematical whiz or you've done a lot of math problems, you know how to make this a perfect square. But if you don't, this is our b value. What we need here is 1/2 b squared. And you just have to memorize that, okay? That's what we add to both sides in order to get a perfect square. So again, what have we got here? Well, b is 4, we said. What is 1/2 of b? Well, that's half of 4. Half of 4 is 2. And if we square that, what do we get? 2 squared is 4. So this is what we need. We'll add that to both sides. Add 4 over here. Add 4 over here. Also, I forgot to mention this earlier, but the astute and video-loving student may notice we already did this problem. We did this in video 1. This was example 1a, actually. Okay, so here we go. We added that. The left-hand side, this is now a perfect square. We now factor this left-hand side, and that's x plus 2 squared. This 2 right here is always going to be this 2, by the way. If you suck at factoring, notice they're always going to be the same thing. Those two numbers. Anyway, and the right-hand side's 21 plus 4, that's 25. And now we use the square root property, take the square roots of both sides. The square root of the left-hand side is going to give us x plus 2. The square root of the right-hand side is going to give us plus or minus, no forgetting that, square root of 25, which is 5. So subtract 2 from both sides, you get x is equal to -2, plus or minus the square root of 25, which is 5. And you may say, whoa, Jason, you said we did this problem before, but we haven't gotten this answer. Did we mess up? The answer is no. It's not done yet, okay? We can simplify this further. This is -2 plus 5 and -2 minus 5. That's -2 plus 5 is 3. -2 minus 5 is -7. Excellent. Okay? And that's how you complete the square. And this is a good time to complete the square. If you find out that your 1/2 b over 1/2 b squared is a nice number, that's a good time to use complete the square. If hypothetically you find out that your 1/2 b squared is not a nice number, that's not the optimal time to complete the square. So let me show you the hard mode of complete the square for those of you who love fractions and messy mathematics. We got part B over here. Maybe 6p squared plus 7p minus 20 equals 0. In order to complete the square, this needs to be a 1. 6 is not 1. You don't have to be a math instructor to know that. You can tell all your friends 6 is not 1, and they'll believe you. You won't have to convince them. In order to become 1, we have to divide everything by 6. So divide by 6. Woohoo! Divide this by 6. Now it's just p squared. Divide this by 6. Woo! 7/6 p. Things are getting fun. Minus divide this by 6. It's 20/6, which is going to reduce. Aha, now the coefficient is 1. So you're seeing how these problems can become fun. So now again, we need to move this guy over. So we're going to add 20/6 to both sides. P squared plus 7/6 p, leave it blank, equals 20/6. Let's reduce that. They're both divisible by 2. This is 10/3. And again, this is our b. So we go off to the side. Say b is 7/6. So what is 1/2 b? That's 1/2 times 7/6. 7/12. Oh. Now we have to square that. Squaring that is squaring the top, which becomes 49, and squaring the bottom, which becomes 144. And whoa, this is a treat. Okay, and that's what we add to both sides. 49 over 144 equals 10/3 plus 49 over 144. Whatever we add to the left, we have to add to the right. And now you're really going to see how that hint I gave earlier is going to play out, because I don't know how to factor this. If you showed this to me and say, Jason, factor that, I would go, I'd get it eventually, but it'd take a little bit of time. But you, on the other hand, you are in luck because there's a shortcut. This always factors. Remember, just like before I said, just look at your 1/2 b. That's all you need to look at. That's what it factors to. So here, let's look at our 1/2 b, and that's what goes here. We said 1/2 b was 7/12. It's always going to be the same. Just copy it over. Don't even have to think, which is nice. And the right-hand side is 10/3 plus 49, 144. You can use your calculator to help this, but keep it as a fraction. If you're doing this by hand, we need a common denominator, which is going to be 144. So how do we get 144 here? That's a good question. I think we multiply by 48. We need to multiply by 48 over 48. That's 120 plus 24. Yep, that'll do it. So on the right-hand side, we have 480 over 144. That's that first fraction. Plus the second fraction, 49 over 144. And again, you can see how this is not the problem that I recommend completing the square for. If you can complete the square and have nice numbers, completing the square is really quick and pretty easy. This is when I would not recommend completing the square. I'm just showing you how to do it, okay? But this is not the optimal method here. So at this point, we can take the square root of both sides. We get p plus 7/12 equals plus or minus the square root of the right-hand side. These have the same denominator, so we can just add the numerators together. This is going to become 529. Woohoo! Does it get any better than this? I'm going to go through this quickly, because realistically, you're probably not going to complete the square on problems like this very frequently. Subtract 7/12 from both sides, you get negative 7/12 plus or minus all this. And you just have to try to simplify this. The bottom is the square root of 144, which is 12. That's not too bad. The top, you want to split this up if you can. Is there a perfect square that's a factor here? And this is where you just start checking things on your calculator, right? Like, is 529 divisible by 4? That's a perfect square. It's not. Is it divisible by 9? That's a perfect square. It's not. Is it divisible by 16? Nope. 25? Nope. 36? Nope. 49? Nope. It's not divisible by any of the perfect squares that I'm coming up with. Maybe there is something that works, but it doesn't look like it. I'm not going to give you a number this bad on like any quizzes or homework, so don't worry about it. I'll just leave it for now. There might be actually something. I'm kind of curious now. I don't think there is. Oh, it actually has 23 squared in it, I think. Yeah, it literally is the number 23 squared. So the numerator just becomes 23. Again, I'm not going to give you something this nasty. Okay, so then you split this up and you get negative 7/12 minus 23 over 12 and negative 7/12 plus 23 over 12. Not something you can expect in quizzes or homework or quizzes or exams, but I do want to show you how to do it. Okay, so this becomes negative 30/12 and this becomes 16/12, both of which can be reduced. Divisible by 6 is negative 5/2. Divisible by 4 is 4/3. And this is the worst case scenario. For the whole section, completing the square on something this messy is bad. I will recommend the quadratic formula for something like this. And you say, I don't remember the quadratic formula. Well, you're in luck. Watch the next video. Oh, and you can do some problems right now. Do numbers 26, 28, and 30. Complete the square. Get you some good practice.